I'll just share my screen and we'll be underway. Okay, welcome everybody. How's everybody today? Everyone's afraid to talk now? Okay, well, let me know
Good
you
for
can.
today.
All right, you can at least hear me, right, Ada?
Yes, you are. You are.
Thank you. Thank you for being there. All right, today, October 9th, we got Massimo and Massimo's friend who Massimo introduced. And of course, they're here to share their P2 gaming system, which quietly appeared on a thread that Ada had started maybe a couple of years ago.
Yeah,
So,
that's one heck of a necro post. The best necro post I've ever seen.
and all of your operating systems run on this, so we'll save the fun for them to talk about. They're in Italy, so we let them talk first so they can go to bed. Also, other things going on. One customer today said, how do I subscribe to your Propeller only email list? And there's a page on our website where it's, okay, it's buried. I'm not doing a very good job. I got to move it somewhere more obvious, but it's under, I'm logged in, so it looks a little bit messy because you're seeing the WordPress view, but it's under Propeller and then Propeller 2. And if somebody could put that into the chat, that link, that would be really appreciated. So that takes care of that. Moving on to like coming meetings. Next month, Nicholas Benison from Germany will come back and he's going to post his step drive object in OBEX for us and go over that. So we can count on that. And then also around December, Terry Trapp will come in and show us the updated Blitzen with his new Propeller P2 Edge controller. And we've seen this before, but he just keeps improving it as he takes over his Tennessee neighborhood with lights and noise and cool stuff. So today, after Massimo talks about this system, Chip will take an inventory on what's available for the micro SD card resource-wise, because I think he's going to go for it and produce the object for that. So, and then before we get started today, I'm going to add myself to the meeting as a clone and just give you a quick look at our manufacturing space.
Recording in progress.
So I mute myself here. Sorry about that.
Oh no, it's doubled up. Oh no, and there's feedback.
I know you don't need two of me. Just be patient. Okay. And I'll stop sharing the screen, take you to the manufacturing space. Okay, your patience is appreciated.
Might be good to cut one of those because there's an echo when you speak.
I know, I'm getting on it. Okay, is that better audio?
Yes.
Okay, good. Sorry about that. It's kind of a pain. Anyway, so just gonna switch my camera around if I can. Where I'm taking you is to the Parallax Manufacturing space. And the reason I'm showing you this is because we currently have capacity to build products. And you can see my highly valued manufacturing leader, Terrell, is building various sensors for our boards like QTIs and probably building jigs, maintaining machines, test procedures, whatever. But we have a complete surface mount line here. Here's our pick and place and our reflow oven. And So that's for the SMT stuff. And then over here, we have our selective solder for through-hole. This is just a giant CNC machine, and we can do through-hole assembly here. We stuff boards, we assemble them products. And if any customers out there have something that might be a product we can build, like if it uses the propeller on it, and we can also review your design and make it
And I don't know if it's on your end, but it seemed to be
suitable for our
picking up.
manufacturing. We're open
Yeah,
to
you're
that.
cutting out a bit.
Things long as that.
Like we just lost him.
Yep.
Okay, I'm back. Do you hear me?
Yeah.
Ah,
Okay, sorry about that. Anyway, I don't know what you heard, but I took you through the manufacturing space, and I was letting you know that we have capacity to build product there on our surface mount and our
build
through-hole
product.
lines. And so if any customers have propeller-based products that they need to put into manufacturing, we are open to doing that at this time.
And Ken, we also have some standard components we use for everything, which are pretty universal. So
Yeah.
if anyone wants us to make something, we can give you that list and you can design using all those components that we already have in inventory and in our system.
Yeah, exactly. Thanks, Chip. I can export you an entire list of our inventory so you could see, but like all the common popcorn parts we have almost 1,000 different components in our inventory.
Oh, and you know what? I could probably volunteer Michael, because he might be up for it. If there is anybody that needs a custom board design, Michael Mulholland has designed all of our products, and he's very familiar with how to do this. So if that's a possibility too. And he also knows all of our inventory parts.
Yeah, like any parallax design that you see, we can use freely in your product too.
Yeah, and I can get you that inventory formatted into a Google Sheet later on.
Okay, any questions about that or upcoming events? Okay, the other last thing on my mind is that I'm actually at Parallax and I'm getting all of our demos working again, which have been decommissioned for a couple of years, with hopes that we can have host a live event here in the spring. So we haven't talked about that or done that in quite a while, but it's time that we bring all of our customers back to the office for a return to office fun. So that's in the future. Okay, shall we go on to Massimo?
Good to go.
Okay.
So, can you hear us? It's seems impossible, but it's our first Zoom meeting. So not sure about our setup. If you can hear us well, or if there is any return or something like that.
yes, audio good, audio good.
Okay, good. So if Ada says okay, we can go. So a quick introduction. We are a small company located in Italy, as you can see. And yeah, I'm speaking, but Massimo is the creator behind this board.
Yes, but Massimo don't speak English. only little.
Yeah, my English is also not that good, as you can see. But yeah, I try to do my best. So Massimo is the hardware engineer of the company, and I'm the software developer. So now I'm just speaking about the board because yeah, the software running of the board is thanks to Ada. So not my work. And
Yes, good software.
yeah, excellent. I have to admit, really impressive. And
Have
yeah,
you seen the earlier recorded meetings where I had meetings where where I showed off some of the funny techniques that I used.
yeah, yeah, we briefly had a look at them, but not not all the live forum, not all. So we have a lot of questions for you, Ada. Maybe one day you will.
You can ask me anytime. You can also send me like anything you can find.
Okay, thank you, Ada. Thank you, Ada. And by the way, that's we developed this board mainly to evaluate the Propeller 2 chip, because we successfully used the Propeller 1 chip on many products. We can say many thousands of chips installed on commercial products. And so now that finally the Propeller 2 is out, we need a way to evaluate their performance. And when we saw the other software, we said, wow. And we realized that the features of the Propeller 2 are excellent. And so we tried with the development board available from Parallax, which are obviously fine, and then condensed everything, or at least what we thought is the most important features, in one compact board, really to be used and tested and enjoyed. So that's why we came with this board, which could be related also thanks to Races. I think the name is Ray Logic, Massimo.
Race logic.
Yeah, it's part of the work is from Massimo, but we also used some PCB design and some hardware parts from
Parallax
the community, I would say.
and also from the Parallax.
Some parts also are almost copied from Parallax module that came with the development kit. So yeah, it's not.
But at the USB hub.
Yeah, also the USB hub is, I think it's from McAfee.
No, it's from.
No, it's made from scratch. Okay, this is this is from us. This is from us. So just to say that Massimo did a lot of design, but also there are also parts took from from other from the community. That was great. And yeah, so maybe you already see the post in the forum which described the board, but I quickly go through the main features. I don't know if you can see the board. Maybe I can. It's also difficult for me. Okay. Half of the board is missing. Let's try.
It has to go further left. Oh.
Okay.
Okay. We'll try. So it's still. Let's try this way. Okay. Okay. So this is the box opened, of course. The Propeller 2 chip with a net sync on it, because it's it's overclocked a lot. I have to admit, I was not aware of that. That can be overclocked that much, and I don't know if it's the normal. If we can expect all the chips can run at 300 megahertz. What do you think? Is that something that we can count on, or it's?
It has a lot to do with the thermal characteristics of the circuit board. So we've gone through several iterations that Michael's designed, and we keep getting it better and better. But you've got to have a big via array under the chip, and it has to dissipate to a few copper planes. And so we have, these little modules aren't that big, but these things can run it. Ada, what do you said you can run this reliably at like 340 or 360?
I think 343 was the one where mine started needing a fan. I think the eval is actually a little bit better, but my edge is also the older Revision A version. Revision B is newer.
Yeah,
and
our latest.
I had Michael tested on some of his edges, and those all worked fine. So I don't know. Just very early unit that I have.
Yeah,
So
they were running at 350 quite reliably with that code. But it also depends on the code, how much you're stressing the chip. If you've got all 8 cogs running, bashing the Cordic or doing really intense instructions, then that's also going to, it's going to heat up quicker. So depends what it's doing as well.
Right.
If you've just got one cog going or a couple of cogs going, or maybe half the cogs going, perhaps 4, then you'll have a lot more. You won't generate anywhere near as much heat. So depends really
Well,
what you're
that kind of
doing.
defeats the point, right?
Yeah, that's true, of course. That's true, of course. But that heat sink's quite neat. And I think AD, you did something. Oh no, you just had a fan running on yours, didn't you? Just gently wafting the air
I
over
had a
it is enough.
heatsink and a fan. I did the heatsink first, but that wasn't enough. But the fan was enough.
Yeah, usually the fan on its own is quite plenty, and it doesn't have to be really high speed forced air. It's enough just to waft the air across it, just to clear it away. But
Yeah,
that's quite
there's
impressive.
someone asked me on the forum the other day about the TJA. It's like at how many for a watt of power dissipation, what is the temperature differential between the chip and the thermal pad on the chip? And I think it's like, I want to say it's about 20 degrees C, 21 degrees C with no airflow. But when you increase airflow, you can get a lot better. Because all the failure that has to do with frequency is ultimately a heat problem, right? As the device self-heats, it hits a failure point. So if you're running at super high frequency and it seems very stable, you have less ambient temperature margin than you would if you were running slower.
Okay, yeah, that's clear. That's clear. But anyway, it's impressive that we can reach such high frequencies. I mean, the maximum frequency in spec is about 180. I'm correct.
200.
Yeah, so we are not twice that. It's was not expected for me.
Yeah, the reason it wound up being able to run so fast is because the guys that did the layout and all the synthesis from our design, they have a lot of automated tools which can predict heat and everything. And so we specified that the chip needs to run at minus 40 to, I think it's plus 85. Does that sound right? And so, and it has to be able to run at 85C, dissipating like a couple of watts. So the layout, I mean the standard cell design and the wiring were really robust to accommodate these, high speeds and high temperatures and still be functional.
Yeah, that's clear. That's clear, and it's great, by the way. So it's all about the thermal dissipation, and that's why we also added. This is an aluminum plate underneath the propeller chip.
Oh, good.
With thermal pad.
Yeah, and there is also a thermal pad, like a thermal paste in between the chip and the aluminum plate. Yeah, we try to maximize the thermal dissipation in some way, because we noticed that everything was running quite well when the case was open. The first prototype was without any heat sink, and we noticed that was running fine for a while, then crashed. Then we added a power dissipation, an heat sink. Then we closed the cover, and sometimes they crash, and then we add the aluminum plate underneath. And this explains why ADA is running a fan too. So it's
it's only needed for Misuyuma because that one's crazy at like 340.
Oh, that's really up there, yeah.
The other ones, they don't need the cooling, and mostly I use the eval board because that's where the green plague of the 96 megabyte board is possible. And
yes,
and this never needs any cooling. This doesn't even have a heatsink installed. This is stock. Great board.
Okay. Yeah, we saw it also with a thermal camera that, yeah, of course, the hot part is really only the Propeller 2 chip, not the RAM, nothing else.
I mean, the RAM is overclocking too, but I guess it doesn't get very hot.
Yeah. Okay, so okay, yeah, this is only about the heatsink. That's it.
And the strange thing is this, for
The RAM.
quattro flash.
Okay, yeah. The other, yeah, Massimo is reminding me that the other strange thing is that these 4 chips are flashes, different flash from. We can boot from 4 different flash, selecting it with this. This is the cover, so
Okay.
we select which chip to boot from by switching this and resetting the board. Maybe we can demonstrate this. Okay, now of course NeoYunge from ADA is running.
Allora facciamo così. I reset.
Now Massimo is resetting it. And switching to ADA already knows what is it, and probably also the other participants. Hexagon. Okay, so we are booting from different flashes. If also this for test purposes for us, or for easily enjoying all the funny software from ADA.
Funny software.
as you wrote.
There are also a chip for latching the memory. When I change, the memory is not changed. Only when I reset the chip or reset the system, select the right flash.
Yeah, now the system is running and we can switch between the flashes, but not in bad apples. That's the point.
Hey, I just looked up an email. I found some information that is important. So on Semi, they did the physical design, except for the custom pad ring. But what they shot for was 150 C junction temperature, okay, at 175 megahertz, and they closed timing at that. So the idea is that if the junction temperature is 150 C, that would be like within an amp, running full steam, dissipating lots of power, with an ambient temperature goal of 85 degrees. So the internal junction temperature was designed to be very, very hot. That's why it can overclock so much.
That's cool. That's cool. Great. Yeah. Also, by the way, also the Propeller one chip that we use it a lot. We can say that we use it every hour project at 96 megahertz instead of the stock.
Oh yeah, that's a nice frequency.
Nice frequency. They're quite usual, and we never had a single problem on 10,000 or more chips. So nice to see that Propeller 2 chip is even better under this aspect.
Well, we were just lucky on Prop 1. I designed it so it would have what I felt was good margin, but I didn't really know. There was no temperature-based simulation of the chip running ever. We just put big enough buffers in so that we thought this would be sufficient. And it turned out that, yeah, I can run it, 96 reliably. But the first chip that we got only ran at like 40 megahertz. So then we beefed up all the buffers without any knowledge really of where it would make the difference. But we just right across the board went from 8x to 16x size buffers, and that got the frequency way up. But this P2 was designed with a lot more science, not just shooting from the hip.
Yeah, you discover it on the road. So nice.
Yeah, I think I was gonna say I think P1 can actually go 160 megahertz with if you just use one core. I think there was actually and the P2, the P2 seems fine. I haven't seen one not work at 300 megahertz, even with my homemade boards. But There's actually two failures I see. One is when you try to go high, when you try to overclock a lot. One is the overheating, which takes some time, but the other one is like an instant failure. It
Oh
just
yeah,
won't.
there's some really weird stuff that I've seen with some of your boards. Like where you turn it on and the screen is just blue.
Are you talking
How does that
P1 or
happen?
P2?
That's P2.
Hmm.
Like it's not setting up the DAC mode correctly or something. Like it's skipping that instruction or something.
I wonder why.
Yeah, I'm only using 4-layer boards, so I'm kind of impressed. This board here got to
Well,
really
the
high.
weird thing now that I think about it is I think I've seen it blue and I think I've seen it cyan, which cyan, blue and green combined, which implies that like it's not setting the higher pins.
Well, I'm impressed.
And I think this is set using a pin field, so it's supposed to set all three at once.
I'm impressed with this board though. It's four. I heard it was 4 layers, and he's got it to run the high frequency games. So that's pretty good.
This looks like a really good board. It has the chip. It isn't crashing, and it has the 96 megabyte, which is sparable. Well, I think I asked this in the forum, it didn't get an answer. Can it run at fast mode or is it limited to slow mode? Which the original 96 megabyte board is limited to slow mode because it is. Can your board run the memory in fast mode? That's a pertinent question.
Okay. Yeah, this is, if of any interest, this is, you can see on the screen now. I try to share it in a better way.
63.2 degrees, is that maximum?
Yes, this is the temperature with the case closed and open the case and measure the maximum temperature.
Yeah, I made a mess with the zoom. I don't know if you can see the picture if I share it or it's.
Yeah, it looks good. We can see that.
Yeah.
Okay.
So the goal that on Semi met was to have it so that thing could be 85 degrees and run at 175 megahertz. So they're at 60.2 and running probably some way higher frequency, right?
Okay, and this is one. We have another picture. Let me find it.
You know, this is only 180 nanometer, which is a very old process, but it was affordable for us. But if we could get into something like something modern, it would probably cost over $1 million to do. But this thing could be running at like 4 gigahertz or something or so.
Okay, no. So it was the other picture is the same. It's almost the same.
No, ma è uguale, tanto uguale. Sì, se lo trovi, se no.
Could I ask you a question about your heat sink test? So you showed us the big heat sink or the big lump of aluminium, I think you said, that you put in the bottom of the case, underneath the PCB, underneath the chip. After doing that, did you try removing the top black fin heatsink that you've got installed now?
Not yet, honestly, and would be interesting to see what happens. I think that